Hello, and oh, it's 11:11. It's cool. Welcome to this video. So what we're gonna do in this video is first thing I'm gonna do before I forget, is I'm gonna run it. But actually before even that, I have notes here for myself. And I'm trying to not say I say a lot. It's sort of a tick. Gonna try to avoid that. But other than that, this is not, don't expect high production values. So this video, we're going to interpolate through the latent space of stable diffusion. If that sentence made sense to you, this video really isn't for you, but check out the Colab document and feel free to mess around. If that sentence didn't make sense, awesome, we're going to get into it. But first, I'm going to run, well, actually, no, first I'm going to show you how to use this document. So the way you use this document is first thing, you scroll down to if you want to play around for yourself, the following cell is the one to edit. We're going to edit it. We're going to do an interpolation. Our starting point is going to be painting of a bear in working, a sad bear working in an office. And we're going to go from that, and we're going to transform that into, let's keep it a painting. We don't want to give the machine too much to change. Painting of a happy otter. No, let's do something more different than otter. Happy ant. Yeah, happy ant on vacation. Okay, now we're going to run everything. And this will take a minute. So when you do this for yourself, which I encourage you to mess around, like literally what I just did is gonna, unless something breaks, it's gonna work for us. But it's gonna take a minute. So now I ran the document, audience knowledge expectations. The other thing I'll say is I'm gonna try to explain things. If my explanations are saying things you already know, maybe watch this at 1.5 speed. If I say something and you get lost, I'm very sorry. You can comment with a question, and since these videos aren't really getting any views, I'll answer it. Or you could pause the video and Google or ChatGPT, ask what you're looking for. I can't recommend that highly enough, having been a connoisseur of tutorials for the last year or so. So getting loser, we're building intuition. We're just going to build some intuition here. So let me show you the examples of kind of what we're building towards. So this first one is an interpolation. Can I make this full screen? This is an interpolation between painting of a young man. So I gave Stable Diffusion the prompt painting of a young man. And then we walked the latent space to painting of an old man. And this is painting of an old man. And these intermediate steps are just steps along a linear interpolation between the 2 points. And I'll talk more about what that meant in a minute, but I'm just going to point out that this is technically Stable Diffusion's absolute middle between young and old man, but he still looks pretty old. And then we also have, this interpolation is a little more complicated. The other one, I only changed one word. This one I changed from a painting of a race car to a photograph of a bicycle. So that's the photograph of the bicycle. This is the painting of the race car. And then that's the middle in between the two. And then finally, this one was a little more kind of imaginative. This one starts as a watercolor. I think the exact language. What was the exact language? Watercolor painting of an individual strolling on a beach, bit of a mouthful, to a one-line drawing of a spacewalk. Let's see what that looks like. The other thing I'll mention real quick is that, like, I don't, like, this isn't art. Like, what I'm showing you is not art. You could be forgiven for thinking that this is art. It looks a lot like art. But I have friends who are artists, and I just want to say that this isn't art. This is an exercise in, just like the Mean Girls meme says, we are building intuition, because these systems are confusing as hell, but they're also pretty cool. And so let's just check in on, okay, so all that loaded in, that's good. All these packages. I didn't write all this code. I stole it from this person here. And are we making images yet? Oh, we are. Okay. So this is that bear isn't sad at all. But that's the bear working in the office. And then, oh, interesting. So it's halfway between a bear and an ant on vacation. But it's continuing to work. Where are we in oh yeah, I was going to talk about that. So Stable Diffusion works in a pixel space of 512 by 512. We can even kind of look at that maybe real quick, get info on this. So 458 kilobytes, 512 by 512. So that's our space in the pixel space. And just real quick for ourselves, we're going to say, what's 512 times 512? We'll call it 250K. 500, 500, 250K is how many dots there are. However, when Stable Diffusion takes an image prompt, like when I gave it this image prompt of painting of a sad bear working in an office, even though it really, like, if that's a sad bear, I want that bear's job, because that bear looks like the bear is maybe painting, very colorful office. Anyways, the shape, and I can't show you this on the notebook. I actually have a follow-up notebook where this gets a little clearer, but the shape of, you just gotta take my word for it, that the shape of the embedding in the latent space is 1 by 77 by 768. So 1 times 77 times 768 equals 59,000. So that's a 5 times reduction in space, which is exciting, because that means that when we operate around in this latent space, we can do so 5 times faster, because instead of having to tweak 250,000 things, we only have to tweak 59,000 things. So that's and I didn't even really, like, I know that is not an explanation, and it's also probably a lot of what I said was wrong just then, but that's our latent space. It's a reduced space, but because we got to shape it through the training process using neural networks, that space has interesting qualities to it. So let's finish up here. Okay, interesting. Huh. What was the prompt again? We had a painting of a happy ant on vacation. So that's what a happy ant on vacation looks like, I guess. But anyways, that's what this notebook lets you do. And the last thing in this video that I'm going to talk about interpolation. So to go back to one of these examples here, we go from a young man to an old man. And, is the man getting younger? I would say yes. Like, if I mixed up these images and then tried to rank them by like young to old, I think I would do an okay job. I think that guy is definitely the oldest. These two guys kind of look similarly young to me. But anyways, it does an okay job. But what is it doing? So what it's doing is it's interpolating in space. And so the best way to think about that is that let's go into a two-dimensional space and say we start at this point, which is 1, 1, and we end at this point, which is 10, 10, and we interpolate between 1, 1 and 10, 10. All that means is that for each X value that we have over 10 steps, we're just jumping a little bit each time. And then for the Y value, similarly, for each step, we're just jumping up a little bit. And the result is that we get this in 2 dimensions, we get this really neat line, just a nice line from one point to the other, and the steps are linear and the steps are even from one step to the other. And then, oh yeah, and so then I talk about this a little here. Let's take it one step further. Let's imagine that it's not just a Y and an X axis. Let's imagine that these axes actually mean something. Maybe the Y axis is how expensive an object is, and the X axis is how big that object is. So now we have this latent space of expensiveness and bigness. And if we take an item, let's say a brand new BMW. Let's put a BMW somewhere on this grid. Well, it's pretty expensive. I forget, was expense this one, or let's say expense is the x-axis. It's pretty expensive. So we're gonna say it's gonna go somewhere over here. And a BMW is pretty big, especially, I mean, cars are bigger than they should be. So let's say that this is the BMW. And so then what could be down here? Well, down here could be something that's quite small and quite inexpensive. Let's say maybe a cup of coffee. And if we were to interpolate between a cup of coffee and a BMW, we would get a pair of shoes, perhaps, and then like a really nice backpack. And then again, like my imagination runs out pretty quick, but you just keep getting things that are a little bit bigger and a little bit more expensive. And this all the same ideas follow for 3 dimensions. We can interpolate through 3 dimensions. We're just, again, just like before, we're just for X, Y, and Z, we're stepping it up just a little bit each time. So that's what interpolation is. And then what we just did with these images was we interpolated, but we didn't do so through 2 dimensions or 3 dimensions. We did so through 59,000 dimensional space, which sounds frightening, and in a way is frightening. But the cool thing about linear algebra is that you can kind of get away with insane jumps of logic like that. So I think this is all I wanted to talk about today. I've gone through, oh, I'm still here. You might have issues with Colab. I'm on Colab Pro. It costs $10 a month. I'm not going to renew it. I needed it for my academic project. I did try this with regular Colab. It does work. It does take a few minutes, as we saw. We did it in real time, but we did it in real time. It might be slower for you because if you're on a free tier, but this is all free if you have just a Google account. And so the next video, we're going to go to the next notebook, and we're just going to keep building this intuition around latent space. Thank you.